Hi everybody, welcome back. So we're just going to do a quick refresh on a parallel circuit and how to calculate impedance total. So my impedance total for a parallel circuit is always done inversely. So if I have three values, I have my R1, we're going to say it's 5 ohms. R2 is going to be 8 ohms. And my XL, this is a pure inductor, I'm going to say that XL is 6 ohms. So this isn't a right angle triangle. We've moved away from that convention, if you can remember, because my impedance has to be smaller than any one of these values, my impedance total. So it doesn't work for a right angle triangle, but it still works with the concept you've used all along when you make the statement of how we add these inversely. So my 1 over my impedance total is equal to, we just add them inversely, 1 over R1 plus 1 over R2. But here is, that should be R2, here is the most important part to remember. Oh, I might have that a little bit high. When we add these, I'll drop that down a little bit for us. When we add this last one, it has to be 1 over, this we're going to use the convention of an imaginary number. This has to be I of XL, because it's displaced by that value of I, or if you're thinking of degrees, by 90 degrees. I'm just going to scroll that up a little bit so you see what we're getting at. Okay. So, now to input those values into my equation, it's going to equal 1 over 5 ohms. So 1 over 5 ohms plus 1 over 8 ohms plus 1 over I of 6. And this will help get us to calculate our impedance total. So the biggest thing to remember when we put this in is that we don't forget to do the inverse. So as you calculate this, if a value shows up, right, if you just left that 1 over 5 plus 1 over 8 plus 1 over I of 6, you end up with something like 0.365. That's just ZT2. We haven't done the inverse of the total impedance. So I have to do 1 over that value of 0.365. If your calculator allows you to do this, just to hit the invert or 1 over answer, however that works, it's the easiest. It keeps all of the decimal places. But you should end up with an impedance total of 2.737 ohms. Oh, got a little email notification there. That's okay. So that's what my impedance total is for this circuit. So if you've done it in a little bit of a different method, totally fine. But this is nice and simple, really straightforward for us to calculate. No fancy things at all with this. Just the kicker is to remember that that imaginary value, using that convention of the complex numbers, so that's added at the appropriate displacement. So I hope this has helped. I look forward to seeing you again. If you need any assistance, feel free, reach out, let me know.